Good day, everyone. We are the Group 6, and our report will be about Chapter 15, Trim. We're going to solve and learn how to get the new draft by applying such calculation. But first, let's have our objectives. Objectives: illustrate and analyze the problem presented. Next will be to calculate the new draft on the effect simultaneously loading and discharging of weight. And lastly is apply such formulas to solve the given problem. So this is the exercise that is given to us, the group 6. So the exercise 15, problem number 13 in the chapter 15 of trim. So the problem states that number 13, a ship arrives in port with draft 6.8 meters forward and 7.2 meters aft. 500 tons of cargo is then discharged from each of 4 holds. The center of gravity of number 1 hold is 40 meters forwards of amidship. The center of gravity of number 2 hold is 25 forward of amidships. The center of gravity of number 3 hold is 20 meters aft of amidship. The center of gravity of number 4 hold is 50 meters aft of amidships. Also, 50 tons of cargo is loaded in a position whose center of gravity is 15 meters aft of amidships, and 135 tons of cargo center of gravity 40 meters forwards of amidship, with a TPC 15 tons, MCT 1 centimeter, and 1 centimeter, 400 tons meter, and the center of flotation is amidship. Find the final draft. So this is the exercise and the problem presented. Now let's go to Iligan to present the illustration and where is the given to be
Now,
placed at.
from our given problem, we have our ship arrives in port, which discharges 500 tons of cargo from each 4 holds. Here is our illustration. We have our 4 cargo holds. From cargo 1, we discharge 500 tons, which is 4 meters forward of amidship. Same also for number 2, which is 25 meters from amidship. Cargo hold number 3, we displace 500 tons, 20 meters aft of amidship. And number 4, again, we discharge 500 tons from 50 meters aft of amidship. We also load a weight of 135 tons, which 40 meters forward of amidship. And from 15 meters aft of amidship, we load 50 tons. Now, as we remember, when it is belonging the aft of amidship, what will be the sign?
Sign will be positive.
Positive.
Okay. How about the sign from amidship to forward?
Negative.
Negative sign.
Negative.
Very good. Now, we will proceed to calculation that will be tackled by Ms. Luatan.
So as you can see, we have our illustration now. So now let's apply what will be Luaton be explaining. Okay.
So for our weight, our load discharge is negative 500, which is distance from the center of gravity of number 1 is 40 meters forward, which is negative 40. Then next for number 2, center of gravity, which is 25 meters forward, or negative 25. Then for number 3, center of gravity, we have 20 meters for aft. And for number 4, we have 50 meters aft, or positive 50. Then also 135 tons of cargo whose center of gravity is negative 40 meters. Then for 50 tons of cargo whose center of gravity is positive 15 meters aft of amidship. So for the moment of change of trim, we have weight times distance. Negative 500 times negative 40 is equals 20,000, which is in astern.
So we put it in
Negative, uh, negative 500 times negative 25 is equals 12,500. Then negative 500 times positive 20 is negative 20,000, which is in forward. Then negative 500 times positive 50 is
25.
25,000. Positive 135 times negative 40 is negative
5,400.
5,400. So be forward.
Then positive 50 times positive 15 is
750.
750.
Astern.
The total for the weight or load discharge is negative 1,815 tons. Then the total of astern is 33,250, and for forward is
40,000.
40,400. So the moment change of trim is 40,400 minus 33,250 is equals 7,150.
So
Thank
now
you.
we as applying the table, we are now have our moment change of trim and the other given. So now let's move on to Dustin Chu for the next explanation.
So our total cargo discharge is 2,000 tons, and our total bunkers loaded is negative 185 tons. So our net weight discharge will be 1,815 tons. So we need to solve the bodily rise and use its formula, small letter W over TPC. So our RW, or net weight discharge, is equal to 1,815 tons. And TPC is given, which is 15 tons per centimeter. So 1,815 tons divided by 15 tons per centimeter is equal to 121 centimeters, or in meters is 1.21 meters.
1.21.
Yeah.
So that's for the next one, we'll have Angie for the calculation of other givens.
So, good day, everyone. Today, we're going to solve for change of trim. So, to get the change of trim, we use the formula, which is moment change of trim over MCT 1 centimeter. So, our moment change of trim is 7,150 TM over 400 tons, which is given. So, we divide it. So we get 17.875 centimeters by the forward. So to get the change of draft up, use the formula small l over L times change of trim. Since there is no given, so this big L is for the length of ship, then small l is the 1/2 of length of the ship. So 1/2 times 17.875. So to divide, we have the answer of 8.9375 in centimeters. Then in meters is 0.09.
So that's for the change of trim, change of draft aft calculations. So lastly, we'll now apply the change of draft forward formulas presented by Sheena.
So for the change of draft forward, we have a formula of change of trim minus the change of draft. For the change of trim, we have 17.875 centimeter, and for the change of draft, we have 8.9375 centimeter. And then subtract the two measurement, and we will have 8.9375 centimeter. And for the change of draft forward, we will have a final value of 0.09 meter. So for the table, for the original draft, we have a value for the aft of 7.2 meter, and for the forward, we have
6.8
8
meters.
meters.
6.8 meter. And for the body rise value, we have
Negative
1.21
1.21 meters.
21 meters.
so both aft and forward will be subtracted with negative 1.21 meter, and we will have a value of for the aft 5.99
5.99 meters.
and for the forward we have 5.59 meters.
59 meters.
For the change due to draft, for the aft we will be subtract 0.09 meter, and for the forward will be added 0.09 meter. So 5.99 meter minus 0.09 meter, we have a new draft of 5.9 meter. And for the forward, 5.59 meter plus 0.09 meter, we have a new draft for the forward, 5.68 meter.
Meters.
For the change due to draft, y 0.09 meter is subtracted for the aft.
Since our change of trim is by the forward, so we minus 0.09 meters sa aft. That's why we get 5.9 meters.
And also because by the forward, so the forward will have the increase of draft. So by adding it, we can say that by the forward, we should have the addition of meters. That's all.
Yeah, that's correct.
So now we have here our final solutions, our final drafts. We have for the aft
5.9 meters.
9 meters and forward is 5.68 meters.
8 meters.
So by illustrating the givens and by making a table for different moments, we can now have this final draft, and we can say that we have calculated the simultaneous loading and discharging
Discharging.
of weight.
Charging.
And okay, so that's for our new draft. So that's it for our reporting and that's calculating of simultaneous loading and discharging for exercise 15, problem 13, the simultaneous loading and discharging of weight. We are the group 6 and thank you
Thank you.
for listening.